So the model can have any logo we want. I want it so that people can search up the app and find it. So this here is perfect so that when other people are screenshotting it and stuff, they can use it. Now, the map works for latitude and longitude. So I can actually just move that right now and you'll see what happens as we go closer to the South Pole. That South Celestial Pole starts to rotate. So you see how now it's pointing up, where before when we were at the equator, it was horizontal. And you can go into first person view. So that's one of the huge selling points of like no other app can do that. You can get this. This is like an equatorial grid. So astronomy software can replicate this, but they don't give you the 3D view. So that's what's unique to our app and why it appeals to everyone, because it is scientifically accurate. This is the 1 degree for every 69-mile tilt that happens on both the flat earth and the globe. And likewise, if you're at like negative 80 degrees, your south celestial pole points up. And this model even predicts the 24-hour sun for the Union Glacier camp. Let me reset the joystick so I can move back. So you see how now we'll go through. Actually, let's be very accurate. Let's set the date just so you can see all the features that I've put in so far. Let's go to December 20th. And yeah, okay, the time has now been correctly set. So then as we cycle through the time, see how that sun perfectly stays up? Okay, good. I wanted to make sure I'm still recording this. This is going to be a good video, actually, of the app. So yeah, see how it shows the sun's orbit? And this is astronomically correct. This stuff can be verified using sun calculators online and a lot of like the software that we would use. Like I like Stellarium. I know Emma, you like what is it? The sun date time calculator, but this combines all the features of everything into one single app. Now let me go into the first person view just so that you really see how powerful it is. So where is the sun? So see how the sun's right there? It's from the horizon, and I can figure out what degree of tilt it is. So let me leave that view and see. So it should be about 23 degrees from the horizon. And I know on my compass, it's showing I can point about southwest 264. I'm not sure how accurate that is. I still got to do some more algorithmic tests and stuff, but the tilt from horizon has been really accurate. Another amazing feature is the GPS location. So let me go to the menu, push GPS, and I can turn it on and allow the app to know my location. Not everyone's going to want to do that, but now we can see that I'm over here in Belize. Let me adjust now the time. So I know my sunrise is around 6. Is that set? Oh, because we're still in December. Oh, okay, okay. Now I know why. It's not that the model's not working, it's that we have the wrong date. So what are we right now? We are August or September 1st. Okay, so now set the model to September 1st, and what I'm saying is true. This is how the sun rose today. It was about 6 o'clock when it starts to rise, and this is that 5 degree tilt from the horizon that we can see in 3D, or go right into that first person view and look for where it is. It'd be over on the east side. And yeah, and then I can get out my compass now, look towards that, get out my sextant and verify that the flat earth model is making accurate predictions. And you can use third-party astronomy software as well on the internet to verify that this is true. Now, our app is going to be offline. All these calculations are being done from the flat earth model. So there's going to be no online third-party resources needed. So you can shut off your internet, and these predictions will still be accurate. And let's go to location, just so I want to show you now. Let's turn off the astronomy part. So I make the UI so you can toggle a lot of stuff on and off so that it's like an easy experience to use and that it's still very powerful for doing demos. So let's put now the latitude up. So see that, how the celestial sphere arises? This is our perspective. So we know that when we're at the North Pole, Polaris, which is that red dot on the circle, that's the North celestial pole. As we move away, it gets lower about 1 degree. So see that little center? So at the equator, you then have both poles visible. So this is the celestial sphere, and this is what's understood between everyone, flat earthers and globe earthers, as how our perspective works. No matter what, you can go outside, look at that object, and it will be how the celestial sphere has shown it to be. Whether you can physically go to that object or not, that's up for debate. There's two ways to interpret that. We have ours, they have theirs. But no matter what, that's what makes this scientifically accurate. And it's fascinating. So here at the equator, actually, let's go back to my location just so that I know it will be accurate for what we're talking about. I can also go to like the sunset. So like around 6 or 7, my sun will start to set. Let's actually do like a solar noon just so we can see that the angle should be pretty high up. Let's go slightly off time, get rid of the location part and go into, I guess, turn the astronomy part back on. So yeah, 80 degrees, roughly 90, that makes sense. And let's go into first person view. You can see how it is like straight up there. And you can see the lines on the sphere. Like this is the orbit of it relative to us. This is how we see it. So it's really cool because it even supports the Book of Enoch and the portals and gates. It looks like the sun actually does set into the water and can be below the horizon from our perspective. So that's what makes this biblically accurate as well. This is scientifically and biblically accurate because no one wants to show you how it actually looks in 3D, where the sun does actually set and rise. So let's see, it does set and rise from the water for our perspective. And I think it's important to be able to show that to people to see how that looks, especially for those of us who know that this is not the actual sun, but is the apparent sun to us because of how light's bending and stuff. And yeah, we can now model. I'm gonna take a screenshot of this actually. That's a good photo. But the app can now model that as well. And then, yeah, the final part I want to mention is just the joystick. So let's get the astronomy part off so the screen is better. You can touch the screen to move around. And then the joystick on the left is just like using a game controller. So that'll move you closer. And the one on the right is for elevation. So let's say I want to go higher. That helps me go higher. So you can really get a good view of this all and see like how everything does work. So let's go right like over here. Let's be good like closer down to the sun. And yeah, so you can do a lot of like advanced research. So for me, this is going to be a fascinating tool because we can kind of understand a lot of advanced stuff that other people can't really model, and now we can model, and then it's scientifically correct as well. So we can draw like a right angle triangle and verify that, yeah, this is actually 20 degrees from the horizon. And it's fascinating. So when we do those types of events where we want to see, hey, where is the moon? Well, we can get out the Firmament Trackers app, go to our location, see where the moon is, and then go into our first person view mode and see, okay, what does the flat earth model predict? It's going to be like slightly to the side of the sun. So you can like go outside and then you can know when to expect to see the moon, and it will be right. I've been testing this, and before we release it, it'll be 100% accurate. Right now, it might be 90% accurate, and that's amazing. Like, we've come such a long way in doing this. Now, there's other views. So let's go to the bird's eye view and let's get the astronomy part off. So this bird's eye view here will be that overview, like the solar noon map that already exists in the other models. So everything before what I've said is all new. That's what makes our app the best and why everyone needs it. Everything after this is now like the common stuff. So this is the same thing that exists on all the models. You have the sun going around, daylight, and you'll have your personal celestial sphere as well. Let me move down. So you see too how the Firmament Trackers logo is right there. So that's what will brand it kind of. So it's easy for